go. Okay. So a precondition is, with respect to a statement, is what do we know as a condition before the execution of a statement in a program. And as a result, a postcondition is what do we know immediately after the execution of a statement in a program. The analysis of the pre and post conditions of a program can be very useful because we can use that to verify or prove the correctness of an entire program. And this part here just talks about, when you consider the entire algorithm, the precondition of an entire algorithm is the input. How do you characterize the input to an algorithm? Do we know ahead of time that x is guaranteed to be greater than or equal to y? Do we know that z is guaranteed to be the sum of x and y already before you start the execution of the algorithm? That's the precondition of the entire algorithm. But what we are really interested in is the post-condition of the entire algorithm, because the post-condition of the entire algorithm describes what the program is going to do. So if the post-condition, just like this one here, if I can prove the code that I presented a little bit earlier and that the post-condition is exactly this, I have just proven the program will work correctly to find the maximum of two variables. Let me switch back here so it is a part of the recording. So in this case, in this context, if I can prove and derive the post-condition of this code here is in fact z is greater than or equal to y, and z is greater than or equal to x, and z equals x or z equals y, I have just proven that the algorithm will do the right thing to find the maximum of two variables. Are there any questions at this point about the terms? What is a precondition and what is a postcondition? Okay, no questions. And then we'll start with constant assignments and self-referencing assignments, conditional statements, and the loops will be last. We are not going to have enough time to talk about loops. We may be able to get to conditional statements. I'm hoping that we can just cover the first and the second case. I'm not going to read from the notes. When you read the notes, it will be a little bit different from the presentation today, but it is the same material anyway. It is always good to have different ways of looking at the same thing, so that's why sometimes in the class I would choose to present the material in some other way. So from here, we'll start to have some examples first, and then we'll generalize from the examples and say, in general, how do we do it? Okay, but we'll first start with some discrete and concrete examples. Let's say I'm picking one line out of a really long program. This is line 415. And we'll just say that that line is x gets a value of 67. Okay, that's all that we know, about that line. However, I tell you something about the precondition. When I use pre-415, it means it is the precondition of line 415. What do we know immediately before line 415 executes? That's what this is representing. Let's just say it is given to us. Okay, somebody told us that, let's say x had a value of 45. So what this means at this point is, I am told and guaranteed that right before line 415 executes, I know that x always equal to 45 before 415 starts. Is that okay? Does everybody understand the meaning of this precondition here? Don't ask me why, because that's the result of the 414 lines before this line here. Okay. Now, what is the post condition of the same thing, of the same line? The post condition of line 415 is just
x equals 67.
X equals 67. Very good. Okay. Is that making any sense? The precondition is x equals 45, but after the statement executes, then x equals 67. Is that okay? Okay. That's a very simple case. Let's go with something that's a little bit more complicated. Line 52 has y gets 5. Okay, I don't really care what it is. The precondition in this case is a little bit more complicated. Let's just say that we know that x is less than y, and z does not equal to x. That's all that we knew. Now this time it's a little bit more complicated, isn't it? Because I don't know for sure, I don't know concretely what is the value of y. I can only say that y is greater than x. I only know how y relates to x before line 52 executes. And I also know something between z and x, they're not the same. Okay? That's all that I know right before line 52 executes. The question is, what can I say about the post condition of line 52?
Then it's going to be 5. Y is going to be 5 equals.
Okay? So we know for sure that y equals to 5 right after line 52 executes, because that's what the line does. Is there anything else I can say?
X is less than 5.
Well, at least we can say that much, because line 52 does not change x, it does not change z, so the relationship between x and z will still be maintained. Nothing is going to change that at this point. Are we doing okay so far? But what about the other thing, x is less than y?
We don't know that anymore. It changed.
We cannot guarantee that anymore. It may still be true, okay? But we cannot guarantee that anymore. And anything that you cannot guarantee anymore, you have to remove it from the condition, because you can only keep the part that you can guarantee. So are we doing okay with this one? This one is a little bit more complicated, because we introduced, not just, what the value of y is. We don't even know that. We just know that y is greater than x before the statement. But after the statement, we can no longer guarantee the relationship between x and y, but we can add the fact that y has to equal to 5 in this case. And we can also keep the other part, because z is different from x, is not affected by line 52, and that's why we can maintain that claim that z is different from x. Yep.
And how it works, like in a whole program, for example, so we know just line 52 and now what?
I'm using this only as an example. Yep. Okay. Well, let me give you another example. This one is kind of odd. On line 1, I have this program saying w gets a value of 0. Okay. What is weird about this one is the precondition of line 1 is something. Okay, let me tell you what I wanted to express, and then you guys can tell me how to express it. I want to say before line 1, I don't know anything. In other words, I don't know anything about the value of w, I don't know anything about the value of x, I don't know anything about the value of y, I don't know anything at all. Okay? How do I choose a Boolean expression, something that is either true or false, so that it is true nonetheless, but without stating any relationship of the variables or any particular fact about the variables?
Just say true.
Just say true. Very good. Okay, let's take a look at this one again. What exactly does it mean? A precondition has to be true in order for the statement to execute. Okay, we will see later on what happens when the precondition of a statement is false. Okay, so we need a precondition. Every precondition has to be true. And yet, I don't want to say anything. I don't want to say x equals 20 because I don't know whether that's true or not. I don't want to say x is different from w because I cannot guarantee it. I know nothing about my variables. So the simplest Boolean expression to say that it is true and yet I don't know anything is just true. Is that okay? Kind of? Okay. You just have to remember in the previous case, it is just that in the first case, I am guaranteed that x equals 45. So x equals 45 is true before line 415 executes. In the second case, I know that x is less than y and z is different from x is true before line 52 executes. So in this case here, I just know that before line 1 executes, true is true, which is trivial. Okay? But this is how we say that we don't know anything about any variables before line 1. What about post 1?
W equals 0.
Exactly. It's just that. So are we...
And that's all we know. And so, so when we state that, we're saying we know something about W, but we don't know anything about anything else?
Correct.
Okay.
Yep. Okay. Are we doing okay so far with the concepts of the pre and the post conditions specific to these 3 examples? Let's move ahead and talk about, in general, what do we do? Now, what is the general format of an assignment statement? It's actually pretty easy. The general format of an assignment statement is it has a line number, so n is my line number here. It has a variable on the left-hand side. So in this class, I'll just use LHS to represent the left-hand side. And it has the assignment symbol, which is a left arrow. And it also has a right-hand side, which can be a long and complicated expression, can be just a 0, can be 67, can be 5, can be anything on the right-hand side. Are we doing okay so far with the 3 components of an assignment statement? The line number, the left-hand side, which is the variable getting changed, and the right-hand side that specifies the value to update the left-hand side. Yep.
So on the left-hand side, you're never going to have
An expression.
Okay.
Yep. It has to be something that can store a value. And that is universally true for all programming languages. It is not always a variable in some languages, but it has to be something that can store a value. That's the key to the left-hand side of an assignment. But in this class, it's always going to be a variable because we don't have the necessary concept to talk about the other stuff that can be on the left-hand side.
Okay.
Okay. So the way we want to say is if the right-hand side does not refer to the left-hand side, use the forget operation. Okay? Now, don't worry about what is a forget operation. We'll talk about that later. But can we evaluate this part here? Can we say for sure whether the right-hand side does not refer to the left-hand side?
Yes.
Okay, 67 as an expression does not refer to x. 5 as an expression does not refer to y. 0 as an expression does not refer to w. Okay, so in all cases that we have presented up to this point, the right-hand side does not refer to the left-hand side. So now what we want to do is to say, okay, what is the forget operation? The forget operation is to say the post condition of line n is going to be based on the result of forgetting something in the precondition of line n. And what we want to forget would be things that we knew about the left-hand side. Now, after you forget everything that you knew about the left-hand side, you can add something, because you can always now say that the left-hand side has to equal to the right-hand side immediately after line n executes. Is that okay so far, just from the perspective of the concept? Okay, let's not worry too much about exactly how to do it, but in terms of concept, does it make sense? Okay. If I know for sure that on a particular line, we call it line n, which is a number to be filled up later, if we know that the right-hand side does not refer to the left-hand side, okay, then I can use the forget rule. The forget rule is basically a general template to relate the precondition to the postcondition. I cannot claim everything in the precondition is still true because after all, I changed the value of the left-hand side. So that means if in the precondition it mentions anything about the left-hand side, I have to take that out because I cannot guarantee that anymore. Is that okay? The rationale of taking out anything that contains the left-hand side in the precondition. I have one example like that here already. If you look at this line 52 here, in the example that we have talked about, the right-hand side does not refer to the left-hand side, so we can use the forget operation. The precondition stated something about y. Y is greater than x. But because I am changing y on this line here, After the change, I can no longer guarantee that x is less than y. And as a result, I forget that fact that x is less than y in the post condition. Yep.
So if line 52 there, if instead of it being y is 5 or whatever, if it was y is y minus 5,
then we cannot use the forget operation. We have another operation to apply to that case.
but we could still, or I guess plus 5, then we could still know that x would be less than
Yes.
y if we were adding to that side.
Correct. We'll deal with that later.
Okay.
That's a very good question, but we're now
Okay.
focusing on the case when the right hand side does not refer to the left hand side.
Okay.
But that's a very, very good projection to the next topic that we'll talk about. Okay. So are we still doing okay with this part here? Does it make sense, the rationale? Okay. So what we'll do is we will go back to the previous cases and say, okay, well, let's see if we can just apply this rule in general to all the cases that we have looked at up to this point. I'm moving the screen a little bit up, just so that it's projected a little bit higher up, so the people in the back can, it will clear all the heads and all the obstacles in the classroom. Okay. Okay, just making sure it's still recording. And it is. Okay. All right, so let's go back and look at these examples. Okay, I will only copy the first part here because I want to derive the last part. We still have the same line 415, still has the same content. X gets the value of 67, we still have the same precondition. So when you want to find out what is the post condition, the first thing you have to do is to say, oh, does the right hand side refer to the left hand side? So the first thing I notice is the right hand side does not refer to the left hand side. We can use the forget operation. Now when you use the forget operation, it is a very mechanical process. You say the post condition of the same line is the result of the forget operator applied to the precondition of that line. In this case, what is the left hand side? X. Mm-hmm. And what do we say after that? X equals 67. This is the right hand side of the assignment. In this case, 67 is the right hand side of the assignment. So are we doing okay so far with the application of the forget rule, of the forget operation? The next thing you have to do is to expand what is the precondition, because in this case, the precondition is already given to me as x equals 45. Okay, x equals 45 is my precondition. Okay. Does x equals 45 refer to x?
No.
Yes.
Oh, yeah, it does.
Yeah, it uses x. So that means I have to forget the whole thing. So when you have the whole thing forgotten, then it becomes, basically it simplified to true. Or if you want to say, oh, since it's nothing, we just, we also get rid of the end. So the whole thing now becomes just x equals 67. Is that okay? Going from this step to the last step. We are forgetting all the components in the precondition that mentions anything about x. Well, the only component is x equals 45, which mentions x. And that's why we have to forget it. But once we forget this part here, there's nothing left. So you cannot say nothing and something else. So basically you just have to get rid of the and as well. And the only thing that we know at this point is x equals 67. Yep.
What's the reasoning for putting the precondition after? Looks like it's always after the line, line number 415, and then you put the precondition there.
Oh, that's just, because I usually give people the line first, and then I say what is the precondition of that line. You can put it before, it doesn't matter. So is this okay? I mean, the application of, this particular rule, you have to make sure that the right-hand side refer to the left-hand side first, and if it does not refer to the left-hand side, then you just, do it this way. Basically just copy and pasting, portions of the original code and then you expand the precondition, and then you apply the forget operation, and then whatever is left is your answer. It's a very mechanical process. And we want things to be mechanical because that will help us to look at a particular assignment statement and know how to derive the postcondition from the precondition. That's the objective. Are we okay so far? Let's work out one more example, and then we'll move on to the other types of rules. So the other example is line 52, which we have done already. So the question now is, can we use the forget rule? Well, the right-hand side does not refer to the left-hand side. We can use the forget rule, or the forget operation. When you apply the forget operation, it's a very mechanical process. You basically say the postcondition of this line, which is line 52 in this case, is based on the previous condition or the precondition of this line. But we have to remember to forget certain things. In this case, what are we forgetting? Components that contain y. Very good. But after this whole thing is done, we also know that y has to equal to 5 because the assignment will change y to exactly 5. Is this step okay? Does everybody understand how we get to this step here?
Isn't there another precondition? Why don't we list the other precondition, the and z?
We'll expand it. Yeah, but this is the template. This is the template.
Oh, okay.
The next step, I know what you're saying. The next step will basically just be a copy and paste of this entire thing, except the precondition part will be replaced by what we know about the precondition. Like that.
Okay.
So did that answer your question?
Yeah.
I thought that we weren't forgetting that z does not equal x.
We aren't. We're
Because
forgetting
it
anything
includes
that
y.
involves y.
Yep.
Anything that involves y, we're going to cross out.
Okay, but the important part is, do we know how we get to the first part here? The first part is simply stating that we have to get rid of something we possibly have to get rid of something in the precondition. And we can also add that y equals to 5. Going from this step here to the second step is also easy because all we are doing is to expand pre-52 to exactly what it was defined as. But it's a very step-by-step process. You can see that I do not jump any steps. It's very step-by-step. For each step, I only do one simple operation. Okay, now we can actually go ahead and perform the forget operation. The forget operation is to take a look at the entire expression here and then say, what are the components that mention y? Get rid of those components. Okay? If I get rid of the component here with the highlighted portion, anything that mentions y, what do I have left?
Just z is not equal to x.
Yep, so we have z does not equal to x as the only component left, and then you still have the conjunction and y equals 5 at the end. So does everybody understand how we got from this to this? Okay, that's it. That's the forget rule. But you brought up a very good question earlier. So I'm going to use a little separator bar here to basically indicate that we are now starting on a different concept. The other concept is like, okay, let's say on line 17, we have x gets x plus 1.
Okay.
Okay, so now we have the right-hand side actually referring to the left-hand side. And let's just say that in the precondition of line 17, let's start with something simple first, and then we'll go to a more complicated example. We'll start with something simple, as in x has a concrete value as in the precondition. Let's say we know for sure that x does equal to 3 as the precondition. So anyone can take this and trace the program, not even using mathematics, and just trace the program and make a conclusion that x has to equal to 4. Is that making any sense? If I knew that x equals to 3 immediately before line 17, and line 17 is x gets x plus 1, then it is only natural that the post-condition of line 17 will say x equals to 4. Is that okay so far? Okay. So that's an easy case. And then we move on to a slightly more complicated case. Let's say we have line 83. Line 83 is w gets w minus 1. And the precondition this time is a little bit more complicated. The precondition of line 83 is that, let's see, w equals 7 and y equals x. Okay? That's given to me. I know that w equals 7 and y equals x every time I get to line 83 before the execution of line 83. Can someone tell me what is the post condition of this?
W is going to equal 6.
Because line 83 only changes the variable w, it decrements it by 1. Can I keep the other part? Can I still say that y equals x?
Yes.
Sure, because those two variables were not affected by line 83. So I can keep the relationship that I knew before the statement because it is maintained. Are we doing okay so far with this? Okay. So now let's move ahead and
The line 52 one?
Yeah.
No, it's different because now W is being affected, whereas
the case before, the right-hand side does not refer to the left-hand side, but in this case, it does refer to the left-hand side. So we don't throw away anything anymore. We just change. Yeah, we're not forgetting anything. We're just adjusting, what we knew. Okay, so we're keeping the same number of stuff, on the screen, except we are tweaking it, to accommodate for the changes because of the statement, because of the assignment statement. So we'll move on to yet another, statement, 131. And this time we'll have, yet another. The statement itself is simple, but the precondition is incrementally getting more complicated. So in this case, we have y gets y plus 1. Okay, fairly easy stuff, just incrementing. But the precondition is the tricky part because this time I will use something that looks like this. Y times 2 plus z is greater than or equal to 20 times k. Okay? Just for the sake of making it overly complicated for no reason. Okay? This time, what can I say about the post condition? Well, first of all, can I say something about the post condition? If I knew that y times 2 plus z is greater than 20 times k before line 131 executes, can I still say something that relates x, z, and k? Yes. I can still say something.
It's still going to be greater because you're increasing the value of y.
What if I say something like this? What if I say y minus 1 times 2 plus z is greater than 20 times k?
It's y plus 1.
It's y plus 1.
That's y minus 1.
No.
I did not make a mistake.
No, yeah. So in that case,
Oh,
It's
because
the
you're
same as the
subtracting the
initial
y
condition.
from the precondition.
I'm subtracting 1 from y. Okay, now think about it like this. Okay, when I refer to y as the post condition, I'm referring to the value of y after the execution of line 131. Right? How does the value of y after line 131 relate to the y before line 131?
It's greater than.
It's 1 more than what it used to be, right? Okay. So if I subtract 1 from the y after the statement, what do I get?
the same as
The same y as the one before line 31. Okay, what did I know about y, z, and k before line 131? I know this is true, right? So that means if I undo what I did on line 131 by subtracting 1 from the y after the statement, I get back the same value as before, and as a result, the relationship is maintained. Are we doing okay so far with this? Because this is a trickier one, compared to the previous one, because not only do I not know anything about y concretely, it is also in a comparison that is it looks overly complicated. Yep.
When they use the minus, not like plus.
Because minus 1 is the undo of plus 1. Yep.
So if we are shifting this, couldn't you remove the equal to? Because if you added 1 to y, if you added 1 to that side for the multiplication or whatever, I don't see how it could still be equal to
Correct.
the other side.
Correct. But this is more accurate.
Okay.
Yeah, this is more accurate because we are changing, this value, this entire expression is being changed by 2 every single time. So when you remove the equal to, it is true, but it's not very precise. It does not describe the exact relationship. But when you do something like this, it is exact. We preserve basically every single thing that we knew about y from before, and it is just now tweaked to accommodate for the changes that we have made to y on line 131. Okay? But the important part is, do we understand why I use a -1 here instead of a +1? It's because I want to undo what line 131 did to y so that I can go back to the old value of y, then I can maintain the rest of the expression. Is that okay? Kind of?
What end? I mean, it seems like he just did nothing.
Hmm?
Seems like it didn't do anything.
Well, it certainly did something because I still maintain, what I knew between, amongst these variables. And it is different. See, the postcondition is not the same as the precondition. It is off by a little bit. So if I can keep doing this, if I can chain the precondition to a postcondition of the previous statement and keep doing this, I can go from the first statement of the entire program, keep doing this until I hit the end of the entire program, then I can go from the precondition of the entire algorithm and derive the postcondition of the entire algorithm at the end. Then I can prove once and for all whether the algorithm is going to do what I think it should do. Are we okay so far with this? No? Kind of? Yes? Okay.
So that's not actually the postcondition, though. The postcondition would be it's y plus 1 times 2.
No, this is the postcondition. It is the postcondition.
I'm not understanding.
Okay. The other way to see this one, let's go back to this one here. I can also say that this is basically saying, if I undo the operation on line 17 by subtracting 1 from x, then I can maintain the same relationship as before.
Yeah, why would you undo it, though?
Yeah, what is?
Because sometimes you have to do it. Because sometimes, in order to express the postcondition, your only choice is to undo what you did on the statement, so that you can say something about the postcondition of a statement. In this case, in the first example, I didn't have to do it because x started with a concrete value. But it still boiled down to the same thing, because you can see that if I apply the same technique and I undo what the statement did to x in order to maintain the original relationship, it only takes a step of simplification to go from this form to the form that we already agreed on. Is that okay?
Yes.
It is tricky. Okay, it sounds a little bit counterintuitive, but it is actually intuitive.
Okay.
Yeah.
I mean, I get why, kind of why you do it, but I just don't understand why that would be the postcondition as opposed to y plus 1 times 2.
Because I understand what you're asking. It has to do with, okay, let me scroll to that part here. This y here refers to the value of y after line 131 executes.
All right, yeah, I get it now.
Okay. Okay, so now that we have gotten up to this point here, it is necessary for us to develop a slightly different set of vocabulary to explain what the further steps, the other steps that we have to perform. So to do that, the first thing is define what is a function. How many people are familiar with the concept of a function in mathematics? Okay. In this class, we are not going to go through all the really detailed stuff about the properties of a function in mathematics. All we're going to do is to say f of x is a shorthand. If I define f of x to be x plus 1, then it is just defining what is f parent, is going to do whatever is inside the parentheses. In other words, if this is how f is defined, then I can say, okay, what is f of 2? Well, we take whatever is inside the parentheses and add 1 to it, and in this case, it gives us a result of 3. What is f of z?
Z plus 1.
Okay, we take whatever is inside the paren, which in this case is z, it becomes z plus 1, and since we don't know what z is, this is the way we have to leave it. Oh, what about the f of x? It becomes f of x plus 1, right? We take whatever is inside the parentheses, and you'll say, I want to add 1 to it, right? And then we can expand it one more time. What is f of x? F of x is x plus 1, and then the whole thing plus 1 will give us the final answer. If you guys want to simplify, it becomes x plus 2. Is that making sense so far? Okay, it can nest. You can apply it to concrete numbers. You can apply it to variables. You can apply it to any expression. It's basically just taking whatever is inside the parentheses and add 1 to it in this case. Is that okay? Now, let's talk about the concept of an inverse function. F prime of x, is an inverse function of f. Normally, you want to say f to the power of -1 to represent an inverse function. That's the notation in mathematics. But since I cannot do superscript easily with a text editor, this is the way I will do it in this class. It's just f prime. If you're taking calculus at the same time, don't confuse those two notations, because in calculus, f prime is the first derivative of a function. Okay, so in this class, f prime is the inverse of a function, not the first derivative of a function. So let's just say that f prime is the inverse of f. That means, okay, by definition, it means if you apply f prime and then to f and then to x, it should give us x back, okay? If you apply f to f prime and then apply the whole thing to x, it should also give us x back. That's the property of an inverse function. Inverse function is, guess what? Undo. Okay, if f is do, then f prime is undo. Are we doing okay so far with the concept of an inverse function? Now, in this case, in this specific case, if f of x is defined to be x plus 1, how do we undo adding 1 to x?
X minus 1.
Okay, f of prime, it seems to make sense that x minus 1 should undo x plus 1. Can I prove that this f prime is in fact the inverse of f?
Yes.
Okay, well, let's try it. Okay, so we'll go ahead and apply f prime to f of x. So the first thing we'll do is to get rid of the f prime. In other words, we are taking whatever is inside the parentheses, which is f of x in this case, and say we want to subtract 1 from it. Is this step okay? Because f prime of x is just saying we'll take 1 away from whatever is inside the parentheses. In this case, whatever is inside the parentheses is just f of x, and therefore we are removing 1 from f of x. But then we have to expand what is f of x. F of x, according to this, is just adding 1 to whatever is inside its own parentheses. So that means we are adding 1 to x, and then subtracting 1 after that. And what is that again?
X.
That's just x. Okay? So you can do the opposite. You can apply f on the outside and then have f prime in the inside. It should give you x just the same. So that shows you the relationship of a function and its inverse function is a mirror. Okay? If f prime is an inverse of f, then you can say the opposite. F is also the inverse of f prime. They're basically symmetric. Are we doing okay so far? Okay. And let me test you on a trickier one. Let's try g of x. I just don't want to confuse, use the same letter, so I'm using another function, g of x. What if g of x is 1 minus x? What is the inverse of that?
1 plus x.
No. This one is a little bit counterintuitive.
X.
It is the same as the original. It's 1 minus x. Okay. I don't know about that. Can a function be its own inverse? Absolutely. Okay. But in this case, does it make sense that it is the same as the original function? Well, let's try it out. We can prove it. So anytime we think, well, I don't know about that, it doesn't seem obvious to me, okay, just go ahead and carry out this operation and see whether we get x back. Now, g of something is 1 minus that something. Well, in this case, that something is g prime of x. And what exactly is g prime of x? 1 minus whatever is inside its own parentheses, right? And what exactly is that? We are subtracting 1 minus x, so that means we are adding 1, we are subtracting 1 and adding x after we remove the parentheses. Is that okay so far? And then we have 1 minus 1, which is 0. 0 plus x is x. Is that okay? There are quite a few functions that are that is its own inverse. There are trivial cases like h of x is x itself. Then the inverse, guess what, is itself. And then we have g, h, I, j, k. Okay. If we are taking the negation, then the inverse is also just the negation itself. So are we doing okay so far with the concept of what an inverse function is? In this class, I will not ask you really too tricky cases. I will not ask you cases where the function is really hard and you have to find the inverse of that. Most of the time, it's just adding 1, subtracting 1, multiply by 2, divide by 2, that sort of thing. Okay, kind of really obvious cases. Are we good with the concept of inverse functions? Basically, it is a undo operation. Now that we understand the notation of an inverse function, we can now go back and say, can we derive some other rules, just like what we did a little bit earlier? In other words, can we have something that looks like this, but for the cases where the right-hand side refers to the left-hand side? The answer is absolutely. That's the whole point of this whole discussion. Except in this case, we have to change some of this stuff here. So if the right-hand side does refer to the left-hand side, and the right-hand side as an inverse, then we don't use the forget rule. We use what we call the substitution operation. And the substitution operation looks like this. Take this out. The substitution operation looks like this. We take whatever we know about the precondition of line n. Whenever we see the left-hand side, we apply the inverse function to it. So we have f prime of LHS applied to it. Okay, so we have to further define this as f of L, the right-hand side is the left-hand side. Okay. That's the template. That is the template that we are going to use. Are we doing okay so far with the template? I know it's kind of abstract at this point. So let me say that again, but using like regular terms. This is the general format of any assignment statements. Is that good? We have a line number, we have a left-hand side, the variable to be updated, and the right-hand side to specify a value to update the left-hand side. And this is just for notation purposes. Okay, I will define function f of the left-hand side, which is the variable who is getting updated, to be the right-hand side. It's just by definition. This is how I define function f. And the rule is basically saying we have two conditions that has to be true before we can apply the substitution operation. The first condition that has to be true is the right-hand side has to refer to the left-hand side. In other words, when you look at the right-hand side, it has to mention the variable on the left-hand side. X plus 1 is an example, because x plus 1 as an expression of the right-hand side refers to the variable on the left-hand side, x itself. Okay. The second condition means the right-hand side has to have an inverse, which means the function f itself has to be reversible. There has to be an inverse function to f that we call f prime. Because if it is not reversible, we cannot apply this rule. Are we doing okay so far? Yep.
So will that follow even if the inverse is the same as the regular?
Yes. Yep.
Okay. So so it doesn't matter if it's the same as long as it has an inverse.
Yep.
Is there any case where it wouldn't have an inverse?
Correct. Then there are cases.
Okay.
Like 0 times x does not have an inverse. Because once x becomes 0, then there's no way you can go back and say, but what was x before the statement? So there are strange cases where you cannot inverse it. Or x minus x, same thing. If I say x equals or x gets x minus x, you know for sure after that statement x becomes 0. But there's no way to reverse and say, but what was it before x minus x? There's no way to reverse that. And I will explain what this does, but it is just a template at this point. Are we doing okay so far with the overall concept and the template? Okay. And we'll use an example to apply the template. Do you guys want to use a simple one or a complicated one?
How about a medium one?
Okay. Medium. Medium raw. Medium rare. Okay, I think that's a medium rare. Okay, so we'll start with only what is given to us, and then we'll try to apply, what we have learned so far. Okay, the first part is easy. The first part is to say n is 83 because that's the line number. W is our left-hand side because that's the variable on the left-hand side. W minus 1 is our right-hand side. Is that making sense so far? I'm just matching the tokens in the general rule to the exact things on the actual line. Okay, so the first thing I can do is to say, oh, it's easy to define f. F of w is what?
W minus 1.
W minus 1, the entire right-hand side. Okay, that's not hard to do. Does the right-hand side refer to the left-hand side?
Yes.
Okay, the right-hand side does refer to the left-hand side. Okay, grammar. Okay. Does f has an inverse?
Yes.
Okay. F has an inverse. Use the sub operation. Okay. So the sub operation is just this part here. So what we do is to say the postcondition of 83, line 83, is the result of the substitution operation, which is yet to be defined. We'll take the precondition of line 83. We find occurrences of the left-hand side. And who is the left-hand side again? W. And f prime applied to w, because w is the left-hand side. And that's it. Okay? This is the overall picture of when to use the substitution rule. And the substitution operation is to take everything in pre-83, the precondition of line 83. If you find w, replace it with f prime applied to w. That's all there is to it. In other words, it's a very mechanical process to replace certain things with f prime of w. So the next step is to expand what is pre-83. Well, pre-83 is given to us like this. And then I'll just keep the rest. Well, what is f prime of w again?
W plus 1.
W plus 1. Okay. Can everybody see how I went from this step here to the second step? The first thing that I did was pre-83 is expanded as it was defined. The second thing that I did was f prime of w becomes w plus 1, because f prime being the inverse function of w minus 1 is w plus 1. Are we doing okay so far? Is it mechanical so far? Because I want everything to be mechanical. Why do you think it is nice to have everything being mechanical? Black and white, ka-chunk, 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 like this. Because the computer is mechanical. Okay? And it's also easy to grade. I cannot imagine how people can grade classes in art classes. That's just hard for me. I mean, I cannot see how that can be done. If you guys taken art new media classes where they talk about the layout of a web page and stuff like that, I cannot grade those assignments. I mean, I can tell you whether your program is right or not. But I cannot tell you whether your design is good or not. Just take a look at my own web pages, right? Yep, the information is there. That's about it. Okay, so now we have, we want to take a look at this expression here. We take out all the w's, and then we replace every single one of those with w plus 1. Well, that doesn't look too hard. Okay, we just copy and paste it here. And here is my only occurrence of w. So we're going to replace it with w plus 1. Just like that. Okay? And that's the end of the substitution operation. Everything after this is just, simplification. How can I simplify w plus 1 equals 7?
W equals 6.
W equals 6. And the other part, nothing to do about it. That's the answer. Are we doing okay so far? It seems like we're doing a whole lot of stuff to do something that we could do before this, in just a snap.
That's the point. Isn't that the point, to show expanding the steps of it?
Mm-hmm. And also making it mechanical, because now, even though in simple cases it seems like it is a waste of time, but in the case of more complex cases, it is a good thing, because now we don't have to think, oh, I have this big long expressions here, what do? Well, we do exactly the same thing. Exactly. So we take the more difficult case here, which is this one here. It looks kind of nasty, it looks kind of long and complicated, but when we use the rules, it is the same, just the same. Okay, first thing first, we have to define what is function f with respect to this one. So this f is entirely different from the previous one. There are two different examples. So in this case, f of y is defined to be the right-hand side, which is
Y plus 1.
just y plus 1. Do we have an inverse for this?
Yes.
F prime of y is y minus 1. Very good. And the right-hand side, does it refer to the left-hand side?
Yes.
Oops. And f has an inverse. We can use the substitution operation. Okay, but what is the substitution operation? Sub 131, the line number, equals the substitution of the precondition of the same line. We take the left-hand side, which is y in this case, and we replace that with f prime applied to y. Are we doing okay so far? Is that step mechanical?
Yeah.
It's very mechanical. Then we perform another mechanical step. The next mechanical step is to say, oh, but what exactly is the precondition? Because I cannot do any substitution until I know what exactly is the precondition. It is already given to us here. Okay, that's not hard. So we just do a copy and paste here. Okay, and we keep y. What is f prime of y? Y minus 1. Okay. I always use an extra pair of parentheses around y minus 1 because if you take just y minus 1 and you put it into wherever y is, sometimes it can cause problems because of operator precedence. But if you put parentheses around it, then there's no problem anymore. So the last step is really just to carry out the substitution. We take the entire thing, we copy it, we say, oh, we have one y over here, okay, fine, we'll replace it with y minus 1. We are all done. Okay? It is just as mechanical as the previous one, which is a simpler case. Are we doing okay so far with the examples? Okay.
What's the purpose of this? Because we're working with the precondition automatically, and then we're saying the postcondition, but the postcondition is actually like it's the opposite of the operation.
Correct. Let's take a look at this case then. Okay, that's a very good question. The question was, why are we doing this? What is the value of these operations?
I can see if we had a postcondition listed, right? And then we wanted to find out the precondition, then we would do the inverse or whatever, and so that could help us find the precondition.
Isn't it just right now, it's just saying what line 131 is doing in terms of the previous line?
Yes. but we can chain these things. So
Yes, and you
in the
can
next,
chain them together.
yeah, so the next example will show you how we are going to chain these things together. So we'll start with line 1 in this case. So we start with line 1, x gets 0. Then we'll go move on to line 2. We'll say, I don't know, why x gets, okay, how about this? I take it back. Sorry. Okay, we start with line 1, and then we say x gets 2 times x. On line 2, we say y gets x plus 1. On line 3, we say y gets y times 2. And then on line 4, we say x gets x plus 1. Doesn't matter. Okay, so I want to know what is the final result after these operations. Okay, and the problem is precondition is just saying that, let's say the precondition of line 1 is that I know that x is greater than 4. That's all that I know.
Okay.
Okay, so the question is, what do I know after line 4? After I perform all these steps, what can I say about x and y? Are we doing okay so far with this? Okay. Now this is not something that you can do with tracing, because when you're tracing a program, you can only do that when you have concrete values in the variables. In this case, we know something, but yet it is not concrete enough to actually perform a trace. So hopefully the pre and post condition thing can help us to get to the end so that I can say something about x and y, properties about the 2 variables at the very end. Excuse me. So we'll go ahead and start with post 1. How do we get to post 1? Well, we have 2 different operations that we can apply. One is called a forget operation, and one is called a substitution operation. Well, I don't know which one is applicable, so let's go ahead and find out. Does the right-hand side refer to the left-hand side?
Yes.
Yes. Does the right-hand side, does it have an inverse?
Yes.
Okay, well that's good. So what we're going to do is to say, on line 1, we'll define f of x to be 2 times x. And it so happens that it has an inverse function because I can always divide x by 2. Okay? And as a result, I satisfy both requirements because the right-hand side refers to the left-hand side, which is the first requirement. And then the right-hand side also has an inverse function. So we can use the substitution operation. Are we doing okay so far? Okay. So when we use the substitution operation, we can say the post condition of line 1 is based on the substitution operation performed on the precondition of the same line. We take occurrences of x and replace each one with f prime applied to x, which is in the template. The next step is just expand everything that we know about the precondition and the inverse function. The pre one is just x is greater than 4. We replace occurrences of x by x divided by 2. Is that okay so far? Okay. So once we perform the substitution, it is just saying x divided by 2 is greater than 4. Right? If you wish to simplify, we can simplify this because we can always say we can multiply both sides by 2, so we have x is greater than 8. Which makes sense because if x was greater than 4 already and we double it, then we can guarantee that x will be greater than 8 as a result. Okay, now we can handle the second line. Oh, but Tech, you never taught us how to do this part, right? I never tell you guys how to relate the post condition of the previous line to the precondition of the following line. How do they relate?
They're the same.
They are exactly the same. All right. Well, that makes it easy, because now I can claim pre2 equals to post 1, which is what we had already. So we take a look at line 2, and then we say, does the right hand side refer to the left hand side?
No.
No. Okay. We cannot use the sub rule. We have to use the other rule. So we have to say the right-hand side does not refer to the left-hand side, and as a result, we have to use the forget rule. forget rule is saying, okay, the postcondition of line 2 is you take the precondition of line 2, you forget something about it. What do we forget about line 2, the precondition of line 2?
What's on the left-hand side?
What is everything that we know about y?
Yeah, everything about that.
Everything that we know about y, we have to get rid of those. But we can say one thing after this, we know that y equals x plus 1 after this line. Are we doing okay so far? It is the application of the forget operation. So the next line is just expanding what pre-2 is. Well, pre-2 we already know is just this one here. We copy and paste it here. And then we copy the rest of the line. But since x is greater than 8 does not mention y at all, we can preserve it. We don't have to forget it. So we preserve this part and say x is greater than 8. And now, on top of that, we also know that y equals to x plus 1. Are we seeing that we are adding more things that we know about x and y, after the second statement? Yep.
If we were doing this ourselves, we wouldn't have to simplify the final post statement, or is it better to simplify?
You don't have to. You mean, are you referring to this
Yeah.
one here?
Yeah.
No, you don't have to simplify x divided by 2 is greater than 4.
Is it better one way or the other? Or does it depend on the situation?
It's just easier to look, when you say x is greater than 8. In this case, it's easy enough, and the simplified form does help in terms of understanding what it means. So I would do it if I were you, but it is not required. Okay, so now that we have these two done, we can move on to the third one. And it's the same thing.
Are we going to simplify that anymore? I mean, can't we simplify it to x is greater than 8 and y is greater than 9?
You don't need to.
Okay.
So post 3 is, pre-3 is based on post 2. They're exactly the same thing. So we look at line 3. Line 3 is, well, the right-hand side does refer to the left-hand side, and it is also reversible. So we'll go ahead and say that. F of y equals to y times 2. F prime of y is y divided by 2. And then I'm just feeling a little bit lazy right now. That's the nice thing of not using the whiteboard and using a notepad instead of the whiteboard. And now we can just do the rest. Post 3 is the substitution of pre-3. We take occurrences of y and replace every single one of those with f prime applied to y. And since we know what is pre-3, we just copy and paste pre-3. We replace all y's with f prime of y. And what do we have after that? We take this whole thing, paste it, and then the only y we have is right here. So we take that out and replace it with y divided by 2. I forgot one step here, sorry about that. I should have said, what f prime of y is just y divided by 2 in this case. Are we doing okay so far?
So is that the post condition now?
Yeah, that's the post condition of line 3.
Line 3.
Yep. And anyone who wants to kind of simplify that a little bit, there's a little bit of what you can do. You can say y equals to 2x plus 2. Really it says about exactly the same thing, but it's just easier to read. Are we doing okay so far with this? So you can see, the post conditions, keep changing, after, we link one step to the next step. And since we only have one more step to do, we'll go ahead and do it. The last step is x gets x plus 1. And in that case, we say pre-4 equals post 3, because those two statements are sequential, they're right next to each other. And then we say what is f of x in this case. F of x is x plus 1. So f prime of x, the inverse function, is going to be x minus 1. And my clipboard has changed. Forgot. Okay. Are we doing okay so far? We're applying the same rule because the right-hand side refers to the left-hand side, and the right-hand side has an inverse. So Now we say post 4 is the result of a substitution operation applied to pre-4. We replace occurrences of x by f prime applied to x. And then the next step is just an expansion of what is pre-4. Pre-4 is the same as post 3, and this is post 3. Copy and paste it here. And f prime of x is x minus 1. And then in the following step, we take the original expression, paste it here, and then every time we see x, we replace it with x minus 1. Every time we see x, we replace it with x minus 1. Don't forget the other one, because if you do it to one and not the other one, then it won't be right anymore. Okay. So if you want to simplify, it becomes x is greater than 9, and y equals, let's see, y equals 2x. Is that right? That looks right to me. Okay, that's the post condition of these 4 lines of assignment statements. Now, can we test it? Sure, we can test it. So what we want to do now is to double check and make sure that Tech did not make any mistakes, because I'm well known for making mistakes when I use these examples in the class. So you should never trust me. It's not like I try my best to be dishonest. It's just that sometimes I just make mistakes. So we'll go ahead and trace this program. And let's see, I can use the old technique using a spreadsheet to do it. And we'll just type in the whole program. X gets 2 times x. Y gets x plus 1. Y gets y times 2. X gets x plus 1. And line numbers. Okay. And we also have to make sure that we satisfy pre-1, because after all, that is our precondition. So we have to make sure that our precondition is satisfied to begin with. And we'll go ahead and start a new window for our trace. X has to be greater than 4, so that's all that I have to remember. We have line number, we have x, and we have y. There's no comment because we are not evaluating any conditions. In the precondition, I have to do something about x, because x has to have a known value and it has to be greater than 4. Let's say x equals 5. Okay. On line 1, we are going to double the value of x, put it back into x. So x is going to end up with a value of 10. On line 2, y is going to be x plus 1. X is 10. 10 plus 1 is 11. Y is now 11. We go to line 3. It is going to double the value of y. Y is now 22. And on line 4, we are adding 1 to x. X goes from 10 to 11. So this is the result of a trace using concrete values in x and y. The question is this matching our post condition from the post condition derivation? Let's take a look. So switch back to the editor and show it like this. The question is x greater than 9?
Yeah.
Yep. Does y equal to 2x?
Yeah.
Yep. Okay. And you can put any, you can initialize x to any value that is greater than 4, and it will still come out correct. In other words, this will still be a valid description of the values of x and y, regardless of what you use for x and y. In this case, because we are not relying on integers at all, all the math works out whether x and y are integers or just real numbers. In other words, you can start x with 4.00001, and the result will still work out. Okay? So I think this is somewhat interesting because it gives you the ability to describe what a program does, but without needing concrete values in the variables. Question?
No.
Oh, okay.
No. I was trying to see if the module came up.
Okay. Are you reading it from your ebook?
I
Oh,
was.
that is cool.
Yeah.
Now, are you reading the PDF?
I'm
or are
reading
you...
the notes, the things that you put on the actual, on our Moodle site, the PDFs that come up.
Mhm.
Yeah, I can download them to it and
That is-
follow along, and I can take notes on it. I can highlight and stuff.
Oh, you can.
Yeah.
Oh, that is cool.
Yeah.
Okay.
It was just a little hard getting the connection for the school to work.
Yes, our Wi-Fi connection.
Yeah.
It keeps dropping your connection, right?
No, it was getting it to let me get online because
Mhm.
you know how
Because
you have to have your
authenticate.
student ID. Yeah, and this didn't want to do the authentication part of it. It just said, no, you can't connect. Yeah, so we went around it though.
Okay. So are we doing okay with these concepts up to this point? Okay, so I will give you guys a homework assignment, based on this, and you will have to do exactly the same thing. You cannot skip any steps. You have to explain every single step just the same way as I do it in the class. So this would be a very good example to refer to in terms of what I expect from your answer. Obviously, the code that I give you is not going to be like this. Okay, it's going to be a little bit different. Okay, so now that we can handle what? Assignment statements, and we can deal with both types of assignment statements. The ones with the right-hand side referring to the left-hand side, and the ones that has the right-hand side that does not refer to the left-hand side. The next question is, what other things can we do? How about conditional statements? In other words, if I give you a conditional statement, I tell you something about the precondition, can we go ahead and figure out the post-condition of the conditional statement? That's the question. And this is also a good time to just draw a picture of a conditional statement again. Obviously, this part is not going to be captured by today's note because it's not done using an electronic mean. But we already know this. This is nothing new to us. So we have a conditional statement here. The question is, if I tell you the precondition to the whole thing, that's the precondition to the whole thing, I tell you what the condition is. I tell you what to do when the condition is true. I tell you what to do when the condition is false. Can I make a conclusion down here about, the post-condition of the entire conditional statement? The answer is yes.
Yeah.
It is actually not very tricky either with conditional statements. So we'll get started. I don't know how far we can go in 10 minutes or so with conditional statements, but we'll get started. It is also in the notes, so you should probably read it before we start in the next class, just to bring yourselves up to date to the material that we'll be talking about. But it really is not as complicated as most people think it is, including myself. So I'm going to use this again, basically the pseudocode to find the maximum of two variables because we are just so familiar with this code at this point already. We know how to trace it. We know what it is supposed to do. At this time, we want to look at it from the pre- and post-condition perspectives. And I will give you precondition of line 1 is true. In other words, I'm not going to tell you what we know about x and y. X can be greater than y, x can be equal to y, x can be less than y. I don't know anything about x or y, which is the best way to start with this one because I want to show you that we will find the maximum of both of these variables, put it into z regardless of what x and y are to begin with. Is that okay?
So it's just hypothetical,
Hmm?
that it's true?
No, it is true.
It is true.
It is true because it's a trivial case as a precondition without saying anything specific about the variables. Okay. Well, how do we go about this? Because line 1 and line 2 are not sequential anymore. Okay, this is not a sequential. Line 1 is not one statement, and line 2 is not a statement after line 1. Line 2 in this case is a component of the overall structure here. So what you can do, and this is pretty much the only thing you can do, is to say something about pre-2, which is basically saying, if I know that I am about to execute line 2, what can I say right before I execute line 2?
That x is greater than y.
Well, that is absolutely true, but I can also say pre-1 and the condition of the conditional statement. Now, I know this step is kind of trivial, but I have to say it, okay? Because why do I want to, okay, let me just roll back a little bit here. Does it hurt to say that pre-2 is pre-1 and the condition of the conditional statement? Is it wrong to say it?
No.
It is not wrong. Why? I mean, how do I know for sure that pre-1 is still true at this point? Let's just forget about the case where we know it is true to begin with. But how do I know it is preserved?
Yeah, it's on your thing.
I haven't got a chance to change anything, right? Between line 1 and line 2, I don't have any statement that can do anything to the variables. As a result, whatever was true before line 1 has got to still be true before I execute line 2. But I can add something to it, because if the condition was not true, I would not have gone for this path anyway. And as a result, right before I execute line 2, I also know the condition of the conditional statement has to be true. Are we doing okay so far? The opposite of this is pre-4. Pre-4 is basically saying, if I know that I made a decision to go to line 4, what can I say right before line 4 executes? Okay. Pre-1 and not the case that x is greater than y, because it is the other branch, it is the false branch, which means the condition has to be false for me to go there.
So it could be less than or equal to.
Yes, we can simplify to less than or equal to. Now, if I want to simplify pre-2, I can do one thing, because I know what pre-1 is. Pre-1 is true and x is greater than y, and that simplifies to x is greater than y. Oh, really? Does it make any sense? Okay, how can I prove that I can do that simplification? Just because it seems to make sense doesn't mean that it's always right, so we always want to prove that it is right. The way to prove this is to remember how conjunction is defined. We have x, we have y, we have x and y. Okay? X can be true, y can be true or false when x is true. X can be false. Y can be true, can be false when x is false. Are we convinced that these are the only 4 possible cases that we can present to a conjunction? Because each side is Boolean. It can either be true or false, so the total number of cases that we can actually come up with will be just 4. X and y is true. Okay, true and true is true. True and false is false. False and true is false. False and false is also false. That's the definition of conjunction. I'm just presenting it in a table format instead of the one that we have in the notes. Of any particular interest here are the first 2 rows. Okay, why are the first 2 rows interesting for what we are trying to do here?
Because pre-1 is true.
Exactly, because when x is true, when the left-hand side is true, whatever y is, the end result is the same. So that means true and whatever is whatever. Do we have anything like that in normal arithmetics? We have quite a few examples of that thing. 1 times anything is anything. 1 times x is x. 1 times 23 is 23. We also have 0 plus 1, whatever is whatever. Okay, but in this case, it's closer to a 1 times something, because conjunction is kind of like multiplication. Not exactly the same, but close, very close. So that means we can also do the same thing here. We have 3 minutes left. It's just enough time to finish this. So I'm kind of glad that we have just enough time to do it. So this becomes true, and we simplify this to x is less than or equal to y. And then we can simplify the true and something out of it. It just becomes x is less than or equal to y. Okay? Now, we have to go from pre-2 to post-2. Okay, post2 is going to be based on the forget operation because we know I'm not spelling out all the steps here because I'm in a hurry. But we are going to forget everything that we know about z, but I'm going to add the fact that z does equal to x after that statement. Okay, does pre2 mention anything about z? No. Pre2 mentions something about x is greater than y, but nothing about z, so we get to keep all that stuff. Post4, pretty much the same thing. We forget everything in pre4 that mentions anything about z because that's the variable that we are changing. And after this, we know for sure that z equals to y. But since all we knew about, all we knew before line 4 is what x is less than or equal to y, there's nothing for me to forget, nothing to toss away. But we also know that z equals to y after line 4. Okay, the magic moment here is what is post 5. In other words, when the two branches merge and I'm standing after they merge, and I look back and say, what can I guarantee at this point? Well, I don't know, I cannot remember which way I came from. Okay, I'm standing at a junction after the merge and I go, what can be true here? But I forgot which way I came from. So the only thing you can say is at least one of post 2 and post 4 has to be true. Because I can either come from line 2 or I can come from line 4. But I cannot be sure which way I came from. So the only thing you can say is post 5 equals to post 2 or post 4. So in this case, we'll just finish this up in 55 seconds. That's the problem of using an atomic clock. Everything is precise down to the second. It kind of forces you to do the same thing too. This is my conclusion. This is my post condition. The question is, does this tell you that z is the maximum of x and y? It does. Okay? Because x is greater than y and z equals x is true when x is the maximum, and z becomes the maximum as well. X is less than or equal to y and z equals y handles the other case. So this, in fact, will find the maximum of x and y. In 5 seconds, the value of everything that we have done so far is we know this algorithm works regardless of what you throw at x and y. Okay? I'll see you guys next Friday. Have a nice weekend, and don't forget to study. I will give you the homework assignment in the next hour or so.
I'm not sure if I'm so heavy. I haven't been there. Yeah, I just don't follow it.